My name's Darren Holmes, and today in Chapter 3 we're looking at physical computing. Basically what that means is we're going to take our Raspberry Pi Pico, plug it into a breadboard, and plug some external electronic devices to it. So in order to do that, we need to know what your Pico's pins do. So when you look at the illustration that they've given you, you can see that pin 1 is located right here in the top left-hand corner, and pin 2 is labeled just below it. So as you go down, we finally get to pin 20, and just like a regular IC, this particular breakout board starts with pin 21 on the right-hand side and goes all the way up to pin 40. You'll notice pin 39 is labeled for you. So this is our Raspberry Pi Pico, and when you look at it, you can see right here there's a label right beside the pin. So it's labeled pin 1 and pin 2. The rest aren't labeled, so we go pin 1, pin 2, all the way down to pin 20. And then this side would be 21, all the way up to pin 40, and you can see pin 39 is labeled. When you look at the bottom of the Pico, you can see all the pins are individually labeled. What they're telling you is most of these pins are general purpose pins. So they're labeled 0 and 1, and then the next pin is where ground is brought out. So then we have 2, 3, 4, 5, and then another ground is brought out. So these grounds are brought out at several locations just to kind of help you wire this up into a circuit. You'll also notice that when we get up to number 22, there's a few general purpose IOs that are not in here. So you can see the general purpose IO 23, 24, and 25 are not brought out. And then we have 26, 27, and 28. And that's where it seems to stop. Now there's a couple other special pins on here. You'll notice these red lines here. Those are power lines. Now keep in mind, this particular IC works on 3.3 volts. So we have to be very careful when we wire this up to other ICs, because our other ICs work on 5 volts. And if you put 5 volts into this particular IC, it will damage it. You'll also notice on here we have a second line of pins that are labeled ADC. These are for analog to digital. So you can put in an analog signal and your Raspberry Pi Pico will convert it to a digital signal. You'll notice we have an analog ground, and we also have a reference. So these will be talked about later when we actually do an analog to digital conversion. So you notice on the next page they give you some descriptions of these. So the GP is the general purpose input-output pin number. So the thing to keep in mind is that these pins are general purpose. They can be used for an input or an output, or they could be used for analog input. So we have to keep in mind that we have to set up the pin for the correct usage. If you're trying to read an input on a pin you've set up as an output, you're not going to be successful. So I just want to refer you to Appendix A, which is the Raspberry Pi Pico specifications. And it says here, the Raspberry Pi Pico's microcontroller chip is a Raspberry Pi RP2040. So we're going to look into that in a little more detail. And in here it gives you some description of the CPU. It's a 32-bit dual-core ARM Cortex M0+, and it's running at 48 megahertz, configurable up to 133 megahertz if you need a little more speed out of it. It has a clock on it. The thing to keep in mind though, as soon as you unplug your Raspberry Pi Pico, it has no battery backup, so it will lose the time. So Appendix B at the back of the book is a pinout guide. And the reason I wanted to show it to you was each of these general purpose input-output pins can also be connected to a UART. So we've got TX and RX, your basic serial port. We also have where it says I2C. Those can be used as an I2C connector, or where it says SPI. So this is important because each pin can be set up for general purpose I/O, SPI control, I2C, or UART. And in addition, we can also set up some of these pins for analog to digital. So in your book we have a couple of talking points here. Pin GP0. It says, like counting in Python, your Pico's GPIO pins start at the number 0 rather than number 1. And they go from 0 to 29, although some of them aren't broken out as physical pins. So here it talks a little bit about missing pins, but it doesn't actually tell you why. So I want to investigate that a little more. So I went to Wikipedia and I did a search on the RP2040. So you can see the RP2040 is a 32-bit dual-ARM Cortex microcontroller by Raspberry Pi. And if you scroll down a little bit, you can see that they show you where to find the datasheet. So this is the datasheet for the RP2040. The main thing I want to bring to your attention is it's 654 pages long. So there's a lot of information in here. So you can see they have a Chapter 1 introduction. And as you scroll down here, it tells you the details of what's on your microcontroller, why it's called the RP2040. So they break down these numbers for you. But what I wanted to show you was this block diagram of the RP2040 chip. These are the general purpose I/O pins, and there's 29 of them. And these are the peripherals. So there's your two SPIs, pulse width modulation, UART, timer, I2C, and ADC. So each of these must be connected to those general purpose I/O pins. You notice there is the internal oscillator that needs to be connected to a crystal. So all of this is internal to the RP2040. In here we have our memory, we have our ROM. There's those 6 banks of SRAM chips and our USB connector. So I wanted to find out a little bit more about the Raspberry Pi Pico, so I went to Google and I typed in Raspberry Pi Pico schematic. And the second item that came up, it's from proto-pic.co.uk, and you can see it's a PDF. So this is the schematic of your Raspberry Pi Pico. You can see we have a large chip here, which is probably your microcontroller. But we have several other ICs on here that are worth investigating. So let's start with this one that's connected to the USB port. So when you zoom into it, you can see that we have an inductor coil, a capacitor, and it looks like it's coming in. There's V bus, so that's your 5 volts from your USB connector, and that comes into this particular chip here, and on the output we have 3.3 volts. So let's go ahead and look up this IC. It's an RT6150B-33GQW. So looking up that part number in DigiKey, you can see it's an IC regulator buck boost. So what that means is if the voltage is lower than the output voltage, it can boost it, or it can reduce it if it's greater than. So this IC is going to give us 3.3 volts, 800 milliamp maximum. So right now there's 0 in stock, but as we scroll down, we can see if we were to buy one, It's $3.03 at the moment. We can also access its datasheet. So coming back to our schematic of the Raspberry Pi Pico, if we scroll down a little bit, we can see we have the boot select button, and it seems to be connected to this IC. Now this IC is a W25Q16JVUXIQ. So let's see what that looks like over at DigiKey. So bringing it up in DigiKey, you can see under description, it's an SPIF flash, 3 volt, 16 megabit. So 16 megabit, to convert to bytes, we have to divide by 8. So that means this is actually a 2 megabyte of flash memory IC. You'll notice it's SPI. You'll note the unit price is just 97 cents, and we can access its datasheet. So one of the last ICs on here is our microprocessor, and you can see it's the RP2040. So typing that part number into DigiKey, you can see here it's ARM Cortex series microcontroller. The interesting thing is they actually have 8,204 in stock, and we have a unit price of $1.47, and once again we can access that datasheet. So in the top right hand corner you can see the pinouts that were brought out on your Raspberry Pi Pico, GPIO 0, 1, all the way down to 15, 16, all the way up to 22. So what happened to 23, 24, and 25? So if you look at the power supply circuit, GPIO pin 23 is connected right here. So that's using it to monitor some kind of voltage level. GPIO pin 24 is over here. So it's going between a voltage divider. So that's being used to monitor an input voltage. You'll notice underneath the connector, GPIO pin 25 is connected to a green LED, and that's on board your Raspberry Pi Pico. So that wasn't brought out to an external connector. And down in the bottom right hand corner we can see GPIO pin 29, and it says ADC, so that's monitoring something. So that's why those pins were not used on the output on your Raspberry Pi Pico. So the book goes on to talk about some more of our electrical components. I'll show you what these look like in your kit. The first one is the breadboard. So I ordered my parts in from Abra Electronics, so these are their part codes for the components required to do these labs. You can see the most expensive part was that LCD display, because I was trying to use the one that was in the book. If you went with a 2-line display, I'm sure it would be less expensive. I just couldn't find one on Abra's website at the time I ordered these. Total price for all these parts came to just over $60 before taxes. You can buy a complete kit to go with this book. I'll show you where you can locate those. They're stocked now both at Abra and Robot Shop. So if you want to buy a complete kit, you can order the Wave 19693. It's available from Abra Electronics. This is a Canadian price. They're also available from the Robot Shop. Doesn't look like they have any in stock at the moment. When you scroll down, the Robot Shop code for these kits is RB-WAV-261. So these are the parts that came in your parts kit. You can see we've got a big LCD display. We got the Raspberry Pi Pico, and we actually have to solder those header pins on. We've got some resistors, some LEDs, a little buzzer. We've got some RGB lighting. We've got our passive infrared sensor, potentiometer, that's a 10K ohm potentiometer, a push button, a whole bunch of hookup wires, and our USB-A cable to hook up our Pico to the computer. So if you've been doing labs with me, you already have a breadboard. This one's mounted on a metal backing plate with 3 binding posts on there. Just makes it so much easier to hook up an oscilloscope or the digital multimeter and run wires over to your board, rather than using alligator clips, because when you use alligator clips they have a tendency to short out your circuit. So if you have the wave share kit, you can see it comes in a nice plastic box. Unfortunately the breadboard does not fit in that box. So when you look inside, you can see we have the breadboard, the oversized buzzer, the Pico, we have an LCD display, we have 2 PIRs, passive infrared sensors, we have a whole bunch of cables, and in here we have LEDs, resistors, these are the RGB lights, and multiple colors for our buttons. The next component they show us is these jumper leads. These are really nice. You can see this end is the male end and this end is the female end. I'll show you what those look like in your parts kit. So in my kit I ordered a whole bunch of jumper wires. I like these because they have you know, like a solid end on here so you can push them in easier. They come in multiple colors, different lengths. So that's the bundle I ordered for my kits. The wave share kits come with the same bundle that I just showed you, but they also come with these as well. You can see that these are actually female to female, and these ones here are female to male. And it also comes with this one here. So this one is actually used for the LCD display. We have some push button switches in our parts kit, so I'll show you what those look like. So these are push button switches. So the one on the left is what I brought in for my kit. Now if you bought those wave share kits, they came with 3 buttons. And they came with little color coded caps, so you can put little caps on them and they just snap into place. We have some LEDs in our parts kit, so I'll show you what those look like. So if you've been doing some labs with me, especially the digital labs, you know that these things are LEDs. The yellow one gives off a yellow glow, and the green one gives a green glow, and the red one gives a red glow. Remember, the longer leg is the positive lead. The shorter lead has to go towards the lower voltage. We have some resistors in our parts kit. I'll show you what those look like. These are 330 ohm resistors that we use in conjunction with the LEDs. Remember, your LED typically runs about 1.4, 1.5 volts, somewhere around there, and the output from our Raspberry Pi is going to be somewhere around 3.3 volts. So we're going to use these resistors as current limiting resistors so that we don't burn out our LEDs. So these are basically 330 ohm resistors. Our parts kit will contain a piezoelectric buzzer. This is different from a speaker. When you apply voltage to a buzzer, it buzzes. When you apply voltage to a speaker, the cone just moves out. So if you want continuous sound, you have to turn a regular speaker on and off. But with a piezoelectric buzzer, we just apply voltage to it and it will buzz. So this one here on the left is what I ordered in. And if you've got the wave share kit, for some reason it has to be so much larger. So that's not going to sound too good in the lab room. We'll have a potentiometer in our parts kit. So the potentiometer is a 103. So the one on the left is what I brought in the kits. If you have the wave share kits, you can see they're fairly larger. Those pins are going to be a little bit harder to try and get into your breadboard compared to the one that I brought in for my kits. We're going to have at least one passive infrared sensor, a PIR, so it kind of detects motion, but it's infrared motion, so anything to do with heat it will detect. It's on a little printed circuit board with some pins on it that we need to connect to our Raspberry Pi Pico. And there's a whole bunch of electronic circuitry underneath. So this is our PIR. It's a passive infrared sensor. As you can see when you look underneath, there's circuitry there. This is the LCD display module. We're looking for one that has an I2C input. They're also going to be talking about SPI interfaces. So they recommended SIR LCD from SparkFun. I managed to order one in, but it ended up being 4 lines instead of 2 and was rather pricey, around $33 each. So I'll show you what that looks like in your kit. So this is the LCD display I ordered for my kit. You can see it's actually a 4-line display. There's nothing displayed on it right now. Works on 3.3 volts. We have a whole series of connectors here. If you look on the back here, you can see it's the SparkFun SIR LCD. This is similar to the one that they use in the textbook. It does I2C and SPI interfaces, so that's why I ordered this one in. So if you have the WaveShare kit, this is what its LCD module looks like. Now my module that I just showed you was something like $34. So this one here has a little connector on the bottom, and you can see it's in WaveShare LCD. Looks like it's a 1602 RGB module. So there'll be a data sheet for these, so we'll look those up when it comes time to programming them. They talk about reading resistor color codes, so if you're not familiar with the resistor color codes or forgotten them from our digital systems course, I highly recommend that you go over this section of the book. If you're trying to remember the order of these colors, you can think something like big beautiful roses occupy your garden, but violets grow wild. Get some now. So this concludes our video on Chapter 3. Now in our next video, Chapter 4, Physical Computing with the Raspberry Pi Pico, we'll actually be hooking up some LEDs and seeing how we can control them directly from our Pico. So until next time, please don't forget to subscribe, and we'll see you on the next video.